Good evening, good evening, good evening. Welcome all the V enthusiasts to the session number 4 of electrostatics, where we're going to talk about dipoles. Very important topic. So welcome aboard with me, Shreyas, your master teacher, and I hope you have already registered for V.O.T.E, and V.O.T.E is nothing but Vedantu online talent examination, and this is going to give you lots and lots of scholarship, lots of prizes, also the chance to become the Vedantu CEO, and also you might win a trip to NASA. So do not forget to check out the link in the description box below. And welcome aboard. I'm Shreyas, and some of you already know me, some of you do not know me, so that's my introduction slide. And in case you want to know more about me, you can definitely check out my Instagram handle, where I keep updating and posting a lot of videos and a lot of inspirational stuff as well. So welcome. Hello Andrew, hi Yalini, hi PL, hello Shreyas, hi Fatima, welcome aboard, hi Neelam, good evening, good evening, good evening. Nice to see all the warriors, all my warriors are here. Hi Shivangi, thank you for all the lovely hearts. Hi Amu, hi Enthuse FC South India fan club. Nice to see all of you lovely people, very good. Nice to see all of you. Yes, let's get going, and before we get going, do not forget to smash the like button down there. Yes, do that. Yes, first thing you should do is smash the like button and also hit the subscribe button. So what and all did you guys have for dinner? How was your dinner? How was it? Yes, aren't you excited? I'm also excited. Dipoles is a very important topic, and probably you'll also hear about dipoles in chemistry. You'll see that dipole moment and all that. Hi Helen, welcome aboard. Yes, thank you so much Shivangi. Happy Tamil New Year to you too. Already done. Very good Andrew. Thank you so much. So guys, yes, I hope you have already subscribed, and I'm pretty sure. So how many lectures for this chapter? Well, we are going to have around 6 classes. So one more class, and I think that's it. After that, we are going to have a Menti quiz. Yes, so that's it. And then we'll go to Gauss's law. And in Gauss's law, you're going to learn other stuff like flux and conductor properties and how to solve problems on conductors and all that. All right. Okay, paisam. Oh, nice. Paisam is a famous South Indian dish, guys, in case you do not know that. All right. Soundarya Hali, thank you so much. Thank you. Oh, Andrew, dinner is not ready. Looks like you're going to have it during the class or maybe after the class. Thank you so much. Thank you so much, guys. So, guys, there is, just few hours back, beautiful announcements were made by the education minister, and one of the announcement is 10th standard examination cancelled. I mean, look at it. And another announcement, 12th standard examination postponed, the board examination. So a lot of you have the queries like, what about the JEE Mains? Well, no news yet on JEE Mains. Let's see how it goes. There is no word yet. So we are expecting that it might also get postponed, because that's the usual trend. But we are not into rumor mongering. You know that we do not speculate on this channel. We do not just give you some hope and then do not do it, or just give you false ideas and then shatter your dreams. So we are not going to get into rumor mongering. So if you hear some rumors, just discard them. Just focus on your studies. Now regarding next year, remember one announcement was made from boards, and that was the reduction which happened in the syllabus is not going to be valid for next year. Yes, keep this in mind. The reduction of syllabus which happened for 2021 students is not going to be applicable for 2022 students. So there is no reduction in syllabus. So keep that in mind. Okay. Yes, DC Pandey, a one-step solution? No. No, you need other books as well. Yes. Okay. Yep. Breaking news. It was actually breaking. People were so fed up because of the COVID situation and all that. So yes, it was indeed breaking. Okay. Hi Charmi, welcome aboard. And remember guys, if you are new to this channel, the only way I would know that you are present here is when you make friends by chatting with each other, helping each other out, welcoming each other, greeting each other, and saying hi, hello to me as well. Yeah, yes. Oh my God, it is PL's birthday. Wish you a very happy birthday, PL. Yes. Okay. Thank you, Shivangi, so much. Wow, Marvels and Avengers. Wow, very good. Marvels, Avengers are here. Okay. Hello. Hi, Nikita. So guys, it's a long road ahead for all of us, and it looks like we have to study online for the next 1 year. How many of you think that for the next 1 year, you think more or less? Maybe there will be ups and downs, but most of the time you have to study online. So yes, there are a lot of important things that you need to keep in mind while studying online. You have to be dedicated. See, there are a lot of advantages of studying online, because you're going to save a lot of time, you're going to save a lot of fuel, you're going to save a lot of money, you're going to save a lot of energy. So you can use this time for better preparing for next 1 year. And even if you feel that your 11th standard was not so okay and you have a lot of backlogs, it's okay, I understand. You need to focus on 12th standard. Keep 11th standard for 1 day in a week. That's it. And apart from that, please follow our Pathfinder series on YouTube. So guys, hello Khushbu. And if you guys have many more doubts, please write to me on my Instagram handle, that's Shreyas_Vedantu, or even after the video ends, or on any of the previous latest 1 or 2 videos, you can leave a comment below. So if you leave a comment below, I'll reply to each and every comment of yours. So we have to plan ahead. Let me also give you another breaking news, or rather just a news, that the long-term batches on Vedantu have already started, and a lot of students have almost completed the first chapter, which is electrostatics. In fact, the batch where I'm teaching electrostatics is more than half over. So guys, understand there is another batch which is going to start, and the further you delay, I don't know, it's just going to delay your starting process, which will also shift your ending process. That means, you will end at a later stage. You will have less time for revision. The sooner you start, it's better. I'm not sure what exactly you guys are waiting for. So yeah, I mean, I always keep giving you these inspirational quotes so that you stay motivated. Yes. Oh yeah, I know you guys had a great chat with Shimon sir as well. Yep. So guys, because it's a long road ahead, understand you need to take very small steps. Every day when you start covering small chapters, every day when you're attending my lectures or attending my classes on the platform, you're attending my micro courses or any other teacher's micro courses on the platform, slowly you are completing a small part of the syllabus, because it is not possible to cover entire thing or revise entire thing in one small amount of time. Then you won't be able to score really well. So guys, start taking those small steps. And if you are interested in the platform where me and other teachers like Shimon sir, Wasim sir, and all of us are teaching, we are conducting a lot of micro courses. Also, there are going to be tests, and there is an English batch as well. There is an English batch which is starting. So guys, do not forget to check out the description box below, because a lot of amazing teachers out there who are going to conduct all these batches. So do check out the description box, because the courses are available for a very affordable rate for this 1 year, and I'll tell you how to enroll into it and all that using this coupon code. So I'll explain all the details towards the end of the class. All right, so let's get going. Let's talk about dipoles for now. Now this looks so beautiful. What are these lines? Come on minions, come on my warriors, let me know. Cengage is good enough but not completely sufficient. You need to solve previous years, and like I said, if you have more questions, please drop in the comment section after the video ends. Hello crazy gamer, welcome aboard. Okay, yes, these are electric field lines, correcto. Wow, excellent. Oh yes, I remember. I remember, Jai Sachin. Yes, I do remember. Yes, these are field lines. Remember, field lines always originate. Field lines always originate from a positive charge and they end on a negative charge. What do these field lines tell? They tell you the direction of the field. Now remember, what is field? I have told you in the previous sessions. Field is force acting per unit test charge. That's what field was. So if you take a charge which is unit in nature, the force per unit charge is the field. And the direction of the field gives you the direction of the force on a charge which is placed. So they originate and they terminate. You will see the field lines never actually intersect each other. That's not at all allowed. The tangent which is drawn to the field line also gives you the direction of the field. Keep this in mind. Okay, correct. Now, whenever you have a positive and a negative charge of the same magnitude, example, 2 coulomb minus 2 coulomb, 100 coulomb minus 100 coulomb, 79 coulomb minus 79 coulomb. That is called as a dipole. Two poles equal and opposite. That is called as a dipole. But if you have 70 coulomb minus 100 coulomb or 2 coulomb minus 17 coulomb, they are not called as a dipole. So they have to be equal in magnitude and opposite in sign. That's very important. So Nirmal, this is for 11th to 12th moving students. Okay. Now, if this much is clear, yes, if this much is clear, this is how the field lines due to the dipole look like. Now, can you see somewhere close to the positive or close to the negative charge, the field lines are more concentrated? That's where the field is very strong, it's intense. As you go far away, you can see the field lines become very sparse, they are hardly close to each other. When you move far away, then the field line strength decreases. No problem, Kirti. Yes, PL, correct. So, wherever field lines are close, that's where the field is strong. As you move far away, the field line strength is decreasing. Correct. So, what are the different pointers we learned? We saw dipole is nothing but equal charges magnitude wise but opposite sign. That's a dipole. Number 2, in a dipole, the field lines start from positive and end at a negative charge. And number 3, we saw that field lines give you the direction of the force acting on a unit charge. That's what we saw. So this is how beautiful a dipole looks like. And we saw that wherever they are more closely packed, the field is more stronger. Okay. Now that we know what is a dipole, and yes, we also saw that they never intersect. Correct. Thank you for reminding me, Andrew. That also reminds me, and that also tells us that Andrew is listening very carefully. Yes, very good. I hope you guys are listening very carefully. Hello, Niham. Yes, I'm very good. Thank you very much. We just started the lecture. We are talking about dipoles. In case you missed and you joined late, guys, please rewind back a little bit and you will catch up at probably 2x speed. Now, can you think of some examples where you actually see dipole? Hi, Vikram. Yes, you're a little bit late, but it's okay. Just rewind back and come catch up. Are there actual examples around you where you see dipoles? Let me tell you, there are plenty of examples. In fact, our world is full of dipoles. Many examples. Now, you might be wondering, what could be an example? Don't worry, I will talk about it. But before that, let me tell you, a dipole has a particular physical quantity which tells you how strong, how intense, what is the strength of a dipole. The strength of the dipole will be given by the following. Observe. This is a positive charge, so I will put plus Q, plus Q over here. This is plus Q charge. This is minus Q charge. Okay, this is minus Q charge. The separation between them, that is nothing but L. That's the separation between the two charges. Now, many books use 2L. Now, I am not really fond of that 2L because it unnecessarily confuses you. Achha, that was 2L. The actual length is 10 meters. So L's value is 5. Why unnecessary? Keep it as length L. Why do you want to make it as 2L? I am not really fond of that. Okay. Harsh, don't worry. I will come up with it. Oh, by the way, I think April strategy was already given by Shimon sir on this channel just few days back. Just check it out. 15-day strategy or something like that was done on this channel. Hello, Vikram. Yes, we are going to rock it. So, something called as a dipole moment will tell you how strong a dipole is. The symbol for that is P, and it is a vector quantity. Yes, it is a vector quantity. It is basically dependent on the charge and the length. Longer the dipole, stronger it is. More the charge, stronger the dipole. So the dipole strength is based on the charge and the length of the dipole. All right. So that's how it works. So this is the magnitude of the dipole moment. So now what will be the unit? Think about it. Come on, minions. Come on, my warriors. Let me know in the chat box what would be the unit of dipole moment. Let's see how many of you are able to quickly answer this. You should be not getting any points for this. Yes, Bhargav, you're not. Yes, Shivangi has answered. Come on, come on. Capital M or small m? Capital M or small m? Come on, think about it. Yes, coulomb per meter? No, coulomb meter. Yes, coulomb meter. Excellent. Very good. That's the unit. Now, if I talk about the direction, because I said it was a vector quantity, remember the direction is always from positive, and if you have negative, it is always from that minus to the plus sign. So it is always from that minus to that plus sign. So the dipole moment for this system or for this system is towards right side or left side? Left side. Minus to plus. Keep this in mind. So the dipole moment, alright, it's always from the negative charge to the positive charge. Keep this in mind. Yes. Write it down, write it down, write it down. So keep this in mind. I'm going to give you a lot of questions now. Okay. So if you have two or more dipoles, you can add them. Let's say I have a dipole like this, and if I have a dipole like this, so if there are two dipoles, I can add them vectorially. So this will be the net dipole moment because it's a vector quantity. Don't just add them. Yes, Nicholas, dipoles are very important for mains. There are a lot of questions on dipoles, in fact in February as well as in March attempt. This chapter as such is only very important. Now, these are some beautiful examples of dipoles. You might be thinking, is this a chemistry class? Now, hydrogen fluoride, HCl. The electron cloud has shifted towards chlorine. So there is a small negative charge over chlorine and there is a small equal amount of positive charge on hydrogen. Do you see it is a dipole, guys? Do you see that there is a dipole formed over here? Similarly, think about it over here. This is also another dipole, HCl. So you can see, the molecules will attract each other. There will be a weak bond which is formed because negative will attract positive, positive will attract negative. So you can see that the two molecules are attracting each other. These are two small dipoles because the electron cloud has shifted. I hope this is clear. Now, similarly, this is which molecule? Water molecule. Do you see the oxygen has taken that electron cloud? So there is delta positive charge on the hydrogen atom and 2 delta negative charge on the oxygen atom. Delta from here, so 2 delta negative charge. Yes, I hope you can see that. So guys, if I had to ask you what is the direction of the dipole moment for this, the dipole moment is in this direction for hydrogen chloride. For this, again, the dipole moment is in this direction from minus to plus. So this is the dipole moment of hydrogen chloride. If I ask you what is the dipole moment of H2O, if I ask you that what is the dipole moment of H2O, so think minus to plus, there is one dipole like this from oxygen to hydrogen, minus to plus, another dipole like that, again from oxygen to hydrogen. So can you see there are two dipoles from this oxygen to hydrogen? Alright, oxygen to hydrogen. So what will happen? The resultant dipole moment will be like this, the resultant of that. Yes, very good. I hope this is now clear. Everybody understanding why, how we are, relating it to, actual, real stuff around us. So you can see there are a lot of dipoles in fact around us because we are surrounded by molecules. All right, yes, negative to positive. Let's get going with this question. Let's see how many of you are going to get this. So guys, what do we have in this question? We have minus 2q charge, plus q charge and plus q charge. And the question is, what is the magnitude of the dipole moment if this is an equilateral triangle of side L? This is an equilateral triangle of side L. The question is, what is the dipole moment of this triangle? Now, first question might come to your mind that, sir, where is the dipole? Actually, I'm not able to figure out the dipole. It's okay, I'll tell you where the dipole is. For now, try to make a dipole from this given scenario. How to make a dipole? You need equal charges in magnitude but opposite sign. So, forget this 2q, minus 2q, and think of it as minus q and minus q only. Minus 2q is 2 minus q's. Now this minus q and this plus q, do you see that they make a dipole over here like this? Do you see they make a dipole over here like this from minus to plus? Similarly, this minus and this plus will also make a dipole like this. I hope you can see that. Alright, this also makes a dipole. This is P and this is also P. Correct? Now, yes, just like water molecule, correcto, correcto, correcto. Now, the resultant of both of them will be like this, guys. This is P net. So now What is that value? Well, for that, what is the angle between the two dipoles? Think about it. It is 60 degrees. Because this is an equilateral triangle, the angle between the two vectors is 60 degrees. So guys, what will be P net? Use our vector addition formula. Try and recollect our vector addition formula. What was it? A square plus B square plus 2AB cos angle, which is cos 60 degrees. Do you see that? Okay, great. So now P square is common everywhere. So take it outside the root, it will become P. Correct? Take it outside the root, it will become P. P square is gone, so 1 is remaining. Again, 1 is remaining. 2. Those P squares have gone out. Cos 60 is nothing but half. Now 1 plus 1 plus 1 is root 3. So it will become P root 3. But what exactly is the value of P? P is charge into length. Charge into length. Don't take two charges. Any one of the charge into length. So hence, it will be QL into root 3. I think most of you would have got the answer. Very good, my warriors. Excellent, Kirti Haran and Ryu Neha. Very good, very good, very good. Will they repel? Probably they might repel. Yes, this positive charges might repel. They want to go out. But let's say somehow they have been arranged on the triangular frame, just for the heck of it. Okay, Vikram? So they have been arranged and we want to find out the dipole moment. It's like how it is in a H2O molecule or something like that. Yes, that's the answer. Let's get moving. The answer was C. Very good. Hi, Islam. Yes, correcto. All the Nicholas, don't spam. Just write it once. Okay. Yes. Okay. So all the new people, all the new warriors, all the new V enthusiasts, all the new minions out here, welcome aboard. Please make friends. Chat in the chat box. Please, because only then you will interact and you will feel alive. And believe me, everyone over here is over here to help each other. And you know, we are all a wonderful family, and this channel has been made for all the English medium students who want to crack JEE, NEET and other competitive examinations. So welcome aboard. Okay, so now let's take few examples. Good evening. Thank you, Islam. Premchand, I'm very good. Thank you so much. Yes, glad you loved the morning session, Ankit. And guys, if you're already here, I hope you have not forgotten to hit the like button. In case you have forgotten, please hit it right away. And if you're new, do not forget to hit the subscribe button down there. Field due to a short dipole. Let's do this. This is a dipole. It will create a field around it. We just saw, correct? We just saw it creates a field around it. And I want to know what is a field around it. Now the meaning of short, the meaning of this word short is you are far away. That's the meaning of short dipole. You are very far away from the dipole. So if this is a dipole, maybe some 7-8 centimeters, I am some 10-15 meters away from it. Okay, that's the meaning of a short dipole. Now this is the axial position. This is axis. This is a dipole. I am on the axis of the dipole and I am over here and I want to know what's the electric field. Guys, think about it. Rajiv will start next week. Don't worry. Yeah, 2023 students, we are starting next week. Okay, don't worry. Now think about it. Because of this positive charge, at this point, the field will be towards the right side. This positive charge will create a field towards right side. This negative charge will create a field towards left side. Whose field will be more? The field due to negative or the field due to the positive at this point? Come on, think about it. Thank you, Crazy Gamer. Hi, Satyendra, welcome aboard. So whose field will be more? The positive's field or the negative's field will be more? Correct, negative's field will be more. Why? Because it is closer. So in order to find the net field over there, is it right for me to say that the net field will be field due to the negative charge, which will be more, minus the field due to the positive charge, because they are in opposite directions? Think about it. The net field will be field due to negative charge minus field due to positive charge. Field is a vector quantity, so I have, put a minus sign because they are in opposite directions. So keep this in mind. So field due to positive because they are in opposite directions. That's the only reason for me to do that. Yes, is that understood, everyone? I hope everybody has understood this. Okay, now let's do the derivation, which is very interesting. Observe this because this might come in your board examinations as well. Now this is L. From this midpoint till here is X. This is X. Okay, this is some X. I am some X distance away. But look at this. This X is very, very large as compared to L because it's a short dipole. Because the dipole is short, that's why I have put X is very large as compared to the length L. L is very small as compared to X. That's what I have written. Great. Now think, what is the field due to the negative charge? Field due to the negative charge, because of this negative charge. First of all, what is the distance between these two? Think about it. What is the distance between these two? Well, it's not that difficult to figure out that, you know, this much distance and this much distance, both are L by 2 each. This is L by 2, this is also L by 2. So, this is X, this is L by 2, this is X minus L by 2. X minus L by 2, correct. So this is X minus L by 2. So field due to the negative charge will be K, Q divided by X minus L by 2 whole square. Keep this in mind. X minus L by 2. That's a standard formula for field due to a point charge. K, Q by R square. So K, Q by distance square. The distance is X minus L by 2. That's all. Okay. Minus field due to positive charge. Again, K, Q divided by distance. Now what's the distance? X plus L by 2. Do you see that? X plus L by 2 is the distance. So it will be X plus L by 2 whole square. That's what you're going to get. Excellent. Now comes the mathematical magic. Observe. This will become K and Q are common. Correct? K and Q are common. Okay. Now I can write this as, I can write this as probably something like this. Hold on. Okay. This was like this. I will shift this term on the top. I will shift this term, okay, on the top. So it will look like this. L by 2 minus X whole raised to minus 2. Right? I write it this A minus B or B minus A, it's whole square. So it doesn't matter. All right. I just written it on the top. Minus, shift it on the top, it will become X plus L by 2 whole square. X plus L by 2 whole square, or you can also write L by 2 plus X whole square, but with a negative power. With a negative power. Yes. Have you guys understood? I've just shifted these terms on the top. The denominator has been shifted on the top and the value of KQ has been taken out common. Now, I'll take out few things common from here. Look at this carefully. KQ. Okay. How about taking out X outside? Let's take out X. Now you might be wondering, why is Sir doing that? You will see why am I doing that. Take X outside. See what will happen. I'll get X raised to minus 2 and I'll have L by 2X minus 1 whole raised to minus 2. Correct? I have just taken out X outside. Now minus, again take X raised to minus 2 outside and I'll have L by 2 plus X whole raised to minus 2. Oops, sorry. Plus 1 because I have already taken out X common. Yep. So that is the out. Now the reason why I did this, I don't know if you guys understood why I have done this. The reason why I have done this is because it is of binomial form. It is of the binomial form. So nothing, Nicholas, this is pure basic algebra. This is 8th standard algebra or 9th standard algebra. I have not even done 11th standard algebra till now. I've just done numerator to denominator, writing negative powers, positive powers, taking things common. This is all 8th standard or 9th standard algebra. Nothing great till here. Even a 9th standard student should be able to understand till here. Nothing great. Okay? So you should be conversant. Come on. You are supposed to know derivatives and integration. This must be cakewalk. Yes. Oh, L by 2x. Oh my bad. L by 2x. Yes. Sorry. L by 2x. Sorry, thank you, Kirti. Yes, the reason why I did that is because I want to write it in the binomial form. Now, if you remember binomial theorem, all right, binomial approximation, 1 plus x whole raised to n, where this x is small, is approximately equal to 1 plus nx. Try and recollect that. Yes, 1 plus nx. That's the formula, that's the binomial approximation. So let's do that. If you want, we can also write this as 1 minus L by 2x. That's also fine. Alright, it doesn't matter. 1 minus L by 2x. It's one and the same thing. You write it like this because anyways you are squaring it. So it doesn't matter. So what will happen? Let's see. Let's see what will happen, guys. Okay. So I'm going to write it on the top. We don't need anything from the top now. So E will be K and Q are common. Square bracket. X raised to minus 2 is 1 by x square basically. It's 1 by x square. Alright. Or if you want, okay, I'll just keep it like that. This term over here, use binomial expansion. Use binomial expansion. What will happen? 1 plus x whole raised to n. What is x? This whole thing. Now, why is this very small? Look at that. L is very small as compared to the denominator. Look at this equation. X is very large. Denominator is very large. So this number is very small. That's why I can use binomial approximation. I hope this is clear. So this will become 1 plus n. N is minus 2. Okay. Into x. X is this whole thing. Minus L by 2x. I hope now this is fine. And I'll put the bracket over here. So this term is done. Now how about this term? Same thing. Minus. So minus again 1 by x square bracket. Again I'll have 1 plus n. N is minus 2 and x is L by 2x. So bracket complete, I guess, and then I complete the square brackets. Yes. Okay, I hope this is clear. Now look at this. KQ, x square is common. Do you see that? X square is common. So take out x square first. 1 minus is plus. So plus 2 cancels L by x minus 1 because x square has anyways gone outside, and this minus and this minus will become plus. 2 cancels and L by x. I hope you can see that. See, x square has been taken outside. This 1 as it is, 2 cancels, minus will become plus, so L by x. This is minus 1 as it is, minus into minus is plus, 2 cancels, L by x. As simple as that. Now, think about it. What is the next step? 1 and 1 cancelled out. 1 and 1 cancelled out. So what will you get? KQ by x square. And L by x plus L by x is 2L by x. So 2L by x. Now, last step guys over here. So this will become 2KQL divided by x into x square is x cube. And what is QL? What is QL? Think about it. What is the value of QL? QL is nothing but dipole moment. That's it. Such a sweet little answer, and that's it. We are done. That's the answer, guys. I hope now you guys have understood it. Very important proof. Guys, concentrate on the session. Don't fight amongst each other. Okay? Concentrate. Yeah, please. Okay. Great. Very good. Yes, that's dipole moment P. Understood? Yes. Same in gravity. Yeah, everything. Everywhere it will be same. Yeah. In magnetism also you will get a same formula for magnetic dipole moment. Chetra Reddy, watch the replay because you have missed a lot of important parts. So catch up in the replay. Okay. So all those people who are joining in late, please watch, scroll behind and watch from beginning, or else you will lose track if you miss the classes. And if you have missed the previous class, please watch the previous class. Again, it's there in the playlist. Great. Okay. So remember this formula. Now this is a field due to the short dipole on axial point. Similarly, you can do it for this point, which is called as equatorial point. This is called as an equatorial point. This line was called axis. perpendicular to the dipole is called equatorial point. So if you are somewhere on the equator, very far away from that dipole, this positive charge will give a field here, and this negative charge will give a field here, and the resultant will be here. This is the resultant field, the net field, something like this. Think about it. Chandrakala Khatri, you are free to choose any channel after you, but this is an English medium channel for all the aspirants of 12th standard, 11th standard, JEE NEET. Alright, okay, cool. Yes, yes, let's concentrate, please, let's concentrate. Yep, okay. So, by same method, just like before, again using binomial and all that, you will get the value of this. Believe me, the answer is very simple. Again, kp by y cube, there is no 2 over there. So the field at this point is just kp by y. What is y? Y is the coordinate. This is y basically. This is the y coordinate. This was the length of the dipole. Yes, I hope you're going to remember this. Okay, let's get going. Let's get going. Okay, I hope you have written it down. I hope you have written it down. Very important. So method of derivation is just like before, no change guys, just that there will be a vector addition over here. So just take the components and add it. You will see that it's there in your NCERT books and all that. Okay. Yep. Okay. So crazy gamer, I would say that what you need to do is use vector addition in the previous case. So for the previous problem, what you need to do is, where is it? For the previous case, because of the positive charge, there will be a field like that. And because of the negative charge, the field will be like this. The net of those two fields will be this way. Just like we did before, we added the fields vectorially and we got the final answer. So same thing and you will get the answer. Okay, I hope this is fine, crazy gamer. Yep. Now, when you have any other random point, then the formula looks slightly different. What is the formula? I'm not sure how many of you know it, but if you are at some other random point where it makes angle theta, this distance is r, this is the length, okay, this is the length L, then the field at this point, the field at any point is given by similar formula guys, kp but by r cube. Instead of 2 and all that, just put 3 cos square theta plus 1. So crazy gamer, please watch the replay. That's the best thing to do. Okay, just watch the replay. Just go behind little bit. You can watch the replay even in a live session. Just go behind little bit and catch up. Okay, don't worry. You can do that. All right. Cool, crazy gamer. This is the formula and you are supposed to remember that. Now think about it. If you are on the axis, then what is the value of theta? If you are on the axis, then what is the value of theta? Hello, Vedi, join in, welcome aboard, welcome all the warriors. So if you are on the axis, what is the value of theta? Alright, come on, think about it. Yes, 0. And if you are on the equator, then the value of theta is 90. And believe me, you will get the same answer. Just substitute it mentally and do it. Cos of 0 is 1. So 3 plus 1 is 4. Root of 4 is 2. That's it. 2 kp by r cube. You got it? That's for axis. And for equator, theta is 90. Cos 90 is 0. 0 plus 1, 1. Root of 1, 1. Kp by r cube. Yes, you got it. I hope this is clear. Yes, this can be used for both things. So this is the general formula. If you remember this, it's even better. I mean, better to remember this than those two, because this is a more generic formula. I hope this is clear. Yes. Yes. Cool. Great. Very good, guys. All right. Next up, let's get going to some questions. Let's see how many of you can do this. Here's the first question. If EA is the electric field, let's see how many of you are listening. Because of a short dipole on the axis and EE is the field on the equatorial line at the same distance, then compare the following. Come on. Think about it. Yes. So the correct answer is very simple, guys. The correct answer is basically, remember, the field on the axis is always twice as the field on the equator. If you remember the field lines only, that will be more than enough. Like, come on, the field lines were something like this. The field lines were something like this, right? So where is the field stronger? Where is it strong? It is strong over here. It is strong over here. It is weak over here because the spacing is more. It's strong here. So the field on the axis is more as compared to that on the equator. So keep that in mind. All right? Cool. That's the easy way of doing it. Yes. Hello, Pritismita. Wow, what a difficult name, but I hope I got it right. Pritismita, welcome aboard. Yes. Okay. Now, going to the next one. This is the first batch. I'm not sure what you mean by that. This is the only batch on YouTube, but on our platform, we have multiple batches in Hindi and English both. Okay. Akhila, fine. All right. Hello, Yashwant. Join in, bacha. Now let's go to the potential due to a short dipole. Just like a dipole creates field, a dipole also creates potential. Now remember, try and recollect what was potential. Potential was energy per unit charge. U by Q. U by Q. Your energy per unit test charge is called as potential. So guys, the potential due to a dipole, what is the formula? Let's figure it out. It's very easy. At least this one is very easy. Guys, think about it. Is this distance and is this distance from the positive charge not equal? Is this not equal? Think about it. The positive charge and the negative charge, I'm equidistant from both the positive and the negative charge anywhere on that equator. Do you guys agree? Do you see that? Do you guys see that? Yes. Now, if that is true, remember, potential is scalar. So you don't have to worry about the direction. No, there is no direction over there. So the potential due to positive will be equal in magnitude as the potential due to the negative charge, but opposite in sign. But opposite in sign. So that's why the potential at this place will be equal to 0. The total potential will be 0. Think about it. Hi Seema, welcome aboard. Yes, the total potential is 0. So remember this. Remember this. Yes, keep this in mind. Okay, last thing. When you're on the axis, the potential on the axial position will be potential because of the positive plus potential because of the negative charge. Potential because of the positive charge plus potential because of the negative charge. So again, do the same thing what we did some time back, guys. This is L, okay, and this is X, okay, and then potential due to positive is KQ by X minus L by 2, and then potential due to negative charge. Think about it. Why for positive it is X minus L by 2? Because this is X, this is L by 2, this much is X minus L by 2. And because of the negative charge, it will be KQ by X plus L by 2. Now you solve it, use binomial approximation, and eventually you are going to get the axial positions value as Kp by X square. Kp by X square, guys. That's what you're going to get. That's all. That's all. Yes, that's what you're going to get. Understood, guys? Yep. Kp by X square. Do this. Very easy. Yeah, try it out. Excellent. Okay. Great. Nicholas, don't spam. Don't spam. Yep. I hope this is clear. Yes. Or else you'll be put on timeout. Okay. Great. Now, I hope you have remembered all the formulas. The last God formula, so that you don't have to remember these two formulas. In general formula, just like we did it for field. At any angle theta at a distance r from a dipole, the generic formula is just Kp cos theta by r square. That's it. This is the generic formula, believe me. And I'll tell you how. Just make theta as 0. This is for axial position, and for equatorial position, all right, theta will be 90. Now try this out. Try this out. When you put equatorial position, that is theta is 90, cos 90 will be 0. That's it. This whole term will become 0, which is exactly what you expect on an equator. On an equator, when you put theta as 90, the potential will become 0. And on the axis, put theta as 0. Theta is 0. Cos 0 is 1. It will become kp by r square. Exactly. Yes, Ajmal, it will be obviously helpful for NEET. Physics is physics. It won't change. The dipole formula for in JEE and NEET is going to be the same, right? It's not going to change. All right. Let's get going to a question. This was asked in April 2020. Now it looks very difficult. It looks very difficult. But trust me, it's not. Read this first. See what you make out of it. And let's start solving together. Okay, let's start solving together. Let's see how many of you can figure this out on their own and how many of you need help. It's okay. You can take help. That's why you guys are here. There is an electric dipole moment of this much at origin and the field due to this at some other location. What it says is that, you know, you have x, y, z axis. Okay. So at the origin, you have some dipole. And at some location R over here, you want to find what is the field due to the dipole parallel to. Now you will be like, sir, you didn't teach us 3D and all. Guys, it is not a question on 3D. Thank you, Krishna Mohan. Glad you made it to the live lecture. It's not a question on anything else. You just have to use common sense, and I'll tell you how. First thing you should do is just take the dot product of this and this, just for the heck of it. Just take the dot product, P dot R. Just try this out. It will give us very interesting things. Just take P dot R. So minus 1 into plus 1, minus 1 into plus 1 is minus 1. Minus 3 into plus 3, minus 9, sorry, minus 9. Plus 2 into plus 5, plus 10. Oh, the answer is 0. The answer is 0. One more lecture, Vaidehi. Tomorrow will be the last lecture for electrostatics, and after that you are going to have a Menti quiz on electrostatics to check how much you have gained knowledge. Yes. P dot R, if it is 0, then what can you say about P and R? What can you say about P and R? Welcome, welcome aboard. What can you say about P and R? If the dot product is 0, what can you tell, guys? Yes, come on, think about it. Think about it. Yes, 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 think about it. Okay, come on, come on, come on, come on, come on, come on, think, 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 think. Yep, yes, they are perpendicular. Yes, P and R are perpendicular. Krish, somebody said I didn't mention the direction of E. No, I didn't mention the direction of E, right? What direction E was and all that. Okay, okay. So yes, P and R are perpendicular. Now that's it. Think about it. If you have a dipole and if R vector is perpendicular, first of all, try and visualize how the field lines will look. The field lines will look like this. The field lines will look like this, right? This is how the field lines look. So at any point over here, what is the direction of the field? The field is opposite, isn't it, opposite to the vector P? Isn't E anti-parallel to P vector? Think about it. Think about it. E vector is anti-parallel to P vector. Now look where P vector is. Where is P vector? This vector. So a vector which is anti-parallel to this vector will just have exactly opposite coefficients. A vector which is anti-parallel to a vector will have exactly opposite coefficients. That's all in the same ratio. Which of the options have similar values but just opposite signs? Look at that. Minus I, plus I. Minus 3, plus 3. Plus 2, minus 2. I think it is C, guys. It is C. Correct. Correct. Very good. Very good. Excellent. So I hope you can see that. Crazy gamer, it's not B. See, in B, this is not completely opposite. Plus 2. Okay. Should be minus 2. Okay. Yes. Minus 3 is plus 3. But minus I is minus I there. So that's the problem. The minus I. Okay. I hope this is clear. Yep. Yep. Okay. Cool. Let's get going to the next one. Okay. Great. Let's get moving. Okay, let's move on. Let's see how many of you can do this question. Let's see. Whether I just said there are totally, some 5 or 6 sessions for electrostatics, all right, which we have planned. Yeah, after that we are going to have Menti. Yep. Cool. Come on, think about it, guys. The potential due to a short dipole of this much coulomb meter at 1 meter from it on the axis and on the perpendicular bisector is. Let's see how many of you can do this. Come on, think. What will be the potential on the axis and on the perpendicular bisector? Come on, think about it. Let's think about it. Guys, one answer is very obvious. On the perpendicular bisector, the answer should be 0, anywhere here. Why? Because you are equally situated from the positive or the negative charge. So the amount of positiveness will be the amount of negativeness. So potential will be 0. Now, obviously option A gets eliminated. B, C and D, all of them have 0 volts on the second side. So the second answer is 0 volts for B, C and D, but I don't know how much is the potential on the axis. So for that, use our formula and see what do you get. So the potential is Kp cos, because you are on the axis. On the axis, what will you put? 0 degrees, because you are here, right? Or when you are over here, angle is 0 degrees divided by r square. So let's try this out. K is 9 into 10 to the power 9. Dipole moment is 4.5 into 10 to the power minus 10. Cos 0 is 1. Distance is 1 meter, so 1 square. Alright, let's see. What do we get next? 9 into 4.5. So I can write 4.5 as 9 by 2. And 10 to the power 9 into 10 to the power minus 10 is 10 to the power minus 1. 9 nines are 81. 81 divided by 2, 41. 81 divided by 2, come on, think about it, 40.5, right? 40.5 into 10 to the power minus 1. So, because you have to write 10 to the power minus 1, so I guess this should be the answer. Yes, I think some of you would have marked this also. Yep, but that is not the answer, guys. Option C. Beautiful. I hope you guys have understood this. Let's get moving to the next question. Yep, A is not correct. A is not correct. A is in fact ruled out. Yep. Okay, let's get moving. Yes. Now, those of you who want to learn under me, where I'll be teaching and there is a separate class teacher who will be solving all your doubts. In fact, I'm conducting lots of small courses called as micro courses. This is how it looks like. Ray optics micro course, wave optics micro course, modern physics, electromagnetic induction, polarization. What's the advantage of micro course? Let's say there is a 11th standard topic and you are in 12th standard. Now you don't know how to solve the problems on rotational mechanics, which is a 11th topic. You can take up a micro course free of cost and attend it as if it's a full-fledged lecture. By the way, the prices mentioned here is when you do not have pro subscription, but when you have pro subscription, all these micro courses are free. I have conducted Erodov micro course. I have conducted H.C. Verma micro course. I have conducted so many books related micro courses, previous year question micro course and so much. So lots of micro courses, not just by me, but by even Shimon sir, Wazim sir and so many other teachers over here, which you will get in pro subscription. Okay, so keep that in mind. Okay. So micro course, you just need to search. You will not be able to search probably by teacher, but for every micro course that you see, you will see the teacher name. Okay, Kirtiaran, you will be able to see the teacher name under every micro course. Okay, Asmi, you are in 10th standard, so you will not be able to access 11th standard micro course. So if you enter 11th standard, you will be able to attend all the 11th standard micro courses, and if you are in 12th standard, you will be able to attempt and attend all the 11th and the 12th standard micro courses. I hope it makes sense. Okay, in which language? I have taught in English. Most of the teachers teach in English, but also there are Hindi batches separate. Okay, separate batches are there. Yes, it's in English. Whatever I have done, it's in English. And most of the other teachers also teach in English at Vedantu. So that's the specialty at Vedantu. Most of the teachers are English oriented. Okay, cool. Let's get going. Now, the force on a dipole. We are talking about, see, we can, before this we were talking about because of a dipole, what is the field, what is the potential. Now, you take a dipole and place it in front of somebody else. Example like this. Look at these two scenarios. Look at these two scenarios. What are these dotted lines? These are field lines. These are external field. This is external field. Understand that. This is external field. But this is non-uniform. Because I've said non-uniform, that means the field lines, the field can be anyhow. It could be even like this. This could be the field lines. Any random way. It's a non-uniform field. It's not constant. Now, my point is, if I ask you what is the force on this charge, try and recollect what is the force equation. Force is QE. The force on any charge, alright, the force on any charge is basically the charge multiplied by the field, if you recollect it. And the field and the force have the same direction provided the charge is positive. So, you will see the force acting this way on the positive charge, and on this charge the force will be this way. What do you guys think? Will the net force be 0 or not 0? What do you think? Will the net force be 0 or not 0? 0 or not 0? Come on, think about it. Come on, think about it. Is the net force going to be 0? I don't think so. Because answer is, first of all, the directions are not opposite. Number one. One is that way. This one is this way. So the directions are not opposite, number one. Number two, magnitudes will not be the same. Why? Because the field here and the field here will be different. Why? Because the field here might be weak and the field here might be strong, because field lines are not uniformly present. It's a non-uniform field. I hope this is clear. Yes. So hence, understand that the field is not same, forces, directions are not same, so net force will not be 0. Okay. But is the net torque 0 or net torque there? What do you think? Is there any torque acting on this dipole? Yes or no? Come on, think about it. Nicholas, please concentrate. Don't worry about others. Just concentrate on the class and just chat with me. Okay, just interact with me. Okay, come on, think about it. Is the net torque 0 or not 0? I think there is a torque. You can see that clearly. This force is pulling it that way, this force is pulling it that way. So net torque is clearly not 0. Come on, think about it. Yep. Now, this is what I wanted you to learn. Now look over here. In this situation, the force on the positive charge is here. The force on the negative charge is here. Okay, it is like this. Opposite to the field, in the direction of the field. What do you guys say? Is the net force equal to 0 or not equal to 0 in this situation? Come on guys. The field over here is strong and the field over here is weak because it has moved away. Here it is strong, weak. What do you think? Is the net force equal to 0 or not equal to 0? Nope, it is still not equal to 0 guys. You might get confused because the directions are opposite but the strength is not the same. Think about it. Strength is not same because the field is not same. Field is less here, field is more here. So the forces may not cancel out each other. Okay, I hope this is clear. Now, if this much is understood, help me with this. Is net torque equal to 0 or not equal to 0? What do you think? These two forces, will they create a torque or not create a torque? Think about it. Yes, because of non-uniform field. Is the net torque equal to 0 or not equal to 0? Come on, think about it. Yes, the net torque is equal to 0. Correcto. The net torque is 0. Because the forces are acting on the same line. So when you apply forces on the same line, there will be no torque. But when the forces are at two different locations, then it will create a torque. I hope this is clear. Okay. Yes. Great. Okay. Now, if this much is understood, Let's take another scenario and see what will happen. Now this time it is uniform field. Let's see. Let's see what happens in uniform field. Let's do this quickly. Come on. There is a force on the positive charge here. There is another force on the negative charge here. What do you think the net force will be? It's uniform field. What do you guys say? Will the forces cancel out each other or no? Will the net force be equal to 0 or not equal to 0? Equal to 0 or not equal to 0? In this case, it will be equal to 0 because field is same, uniform. Direction of force, opposite. Equal opposite forces, net force is 0. Yes, correcto. Next, net torque. What about net torque? Is it equal to 0 or not equal to 0? Think about it. Is it going to create a torque? Just visualize, no? There is a dipole. I apply force that way and I apply force this way. Will this thing rotate or no? If I apply forces one over here and one over here, is it going to rotate? Obviously it's going to rotate. So net torque is there. It's not 0. Very good. Very good. This situation, force here, force here. Net force is 0 or not 0? Net force is 0. Both equal, opposite. Uniform field, equal and opposite. You can see that. And net torque is also 0 because they are on the same line. They are on the same. My point is, you can have all the scenarios. In fact, in the last 2 slides, we have discussed all the scenarios. Force is 0, torque is 0. Force is 0, torque is not 0. Torque is 0, force is 0. Torque is not 0, force is not 0. All 4 situations are possible under different scenarios. That's my whole idea. And I want you to see that because it involves all the concepts. Yep, same line of action, correcto. Okay, so let's see how many of you are paying attention. Let's see. An electric dipole is placed in an electric field generated by a point charge. A dipole is placed near a point charge. So that point charge will be creating field. So then, which of the following is true? Let's see how many of you can do this. I'll tell you what. If you take a positive charge and if you see the field because of it, the field because of a positive charge will look something like this. And you are placing a dipole. Now dipole means something like this. Alright, so this is a dipole, correct? Now, will this dipole experience torque or will it not experience torque? Come on, think about it. Will this dipole experience torque or will it not experience torque? Think. The torque on the dipole may or may not be 0. Think, because there will be a force like this and there will be a force like this, correct? There can be a torque acting on it. So one of the options says the torque must be 0. Wrong. In fact, there is a torque. The torque on the dipole due to the field may be 0. Well, in this case, the torque is not 0. But look at this situation. Look at this situation. I'll just draw more field lines. Just look at this situation. If the dipole is placed like this is minus, this is plus. In this situation, think about the torque acting on the dipole because the forces will be along the same line. The forces on the positive and the negative charge will be along the same line. So in this case, the net torque will be 0. So the torque may be 0, may not be 0. Hence, the answer which will be marked correct will be D. Yes. I hope this is clear. So both are possible, may be 0, may not be 0. Hence, D is the correct answer. Okay. So let's get moving to the next question coming up on your screen. Now before that, yes, but the strengths will be different. The forces will be different in strength, correct? But they are along the same line. So that's why they will not be able to create any torque. Cool. Okay. Now, no problem, Nicholas. Okay. Now, the torque on a dipole, how much is the value when you keep it in a uniform field? Now, this is something which you should know. So, there is a force here and there is a force here. So, these two forces create a torque. The torque on a dipole, standard formula, remember this. It is QL sine theta into E. External field into QL sine theta, which you can write it down as PE sine theta. This is the magnitude of the torque. PE sin theta. But if you want to write it in vector form, then write it as P cross E, because you got PE sin theta and torque is a vector quantity. So this is in vector form. This is magnitude only. Alright, this is in vector form. You should know this formula. P is the dipole moment vector, E is the electric field vector, P cross E will be the torque. Yes, P cross E. Now, basically, understand guys, if P is there, E is here, the torque will be P is there. Hold your right hand fingers there, P cross E. It will turn it like this. So the torque will turn it in this way, clockwise. Look at that. I hope you can see that. Great. Let's get moving to the next one. Now, let's see if you can solve this question. The electric dipole consisting of two charges, 2 into 10 to the power minus 5 coulombs, is separated by 3 centimeters and placed in this field. What can be the maximum value of the torque? Well, I desperately need an AC and I'm going to look for an AC tomorrow. I always thought Bangalore was a place which was very cool and you don't need AC. So I give up guys, sorry. You need AC in Bangalore, okay? So we need AC. Yep. So some of you are saying option C. Well, let's try this out. Maximum torque. Tau is PE sin theta. When will torque be maximum? When sin theta is maximum. And what's the maximum value of sin theta? It's 1 when theta is 90 degree. So tau max is PE. And what is P? It is charge into length. Now just substitute everything. Charge is 2 into 10 to the power minus 5. Length is 3 centimeters. And field is 2 into 10 to the power 5. Yep. And we have 2 into 3 into 2, which is 2 to the 4, 4 3 is 12. 10 to the power minus 5, 10 to the power 5 goes, and we have 12 into 10 to the power minus 2, which is over here. Yes, that is the correct option. Okay, very beautiful question on simple harmonic motion. You take a dipole, put it inside a field. The question is, it will oscillate. It will oscillate. Yes, it will oscillate. So, find the frequency of oscillation. That's the question. Let's figure this out. It's not that difficult. So, you have a dipole and it is placed inside a field and you deflect it by some angle theta. The dipole will experience torque and believe me, it will oscillate. Yes. Saksham, the drills was for flash. What we have done is, instead of drills, we are giving you Menti quizzes. Okay, number 1. Number 2, I'm giving you after every lecture a homework question. Number 3, if you want all the assignments, please join the pro subscription. In pro subscription, after every class, you will get assignments. So understand, we are doing Menti quizzes after every chapter. Alright, so after electrostatics, there will be a Menti quiz and I'll be giving you DPPs. Plus, there will be 0 to hero sessions. Plus, there will be, a lot of revision sessions which will go on the way where you will get a lot of questions. So don't worry, bacha. We'll try our best. Don't worry, okay? Yes. Now, the question is find the time period. Now to find the time period, no problem Saksham, we'll try our best to give you as much as possible freely, but if you can afford, I'll tell you, there is a simple way you can afford. Just wait till the end of the class, I'll give you a very superb plan by which you will be able to afford. Believe me, you will be able to afford. And you will be only surprised why you didn't tell me this before if this was so cheap. It's not about the discount coupon, it's something else. I'll show that to you. Okay, so hold on. Now, let's think about, in an oscillation, whenever the force is proportional to displacement, it is SHM. But when a particle oscillates angular wise, the torque should be proportional to theta. So first of all, what is the value of torque? Torque is PE sin theta. Is torque proportional to theta? No. But if theta is small, remember there is an approximation that says sin theta is approximately theta when theta is very small in radians. When theta is very small, that time, sin theta's value is equal to theta. So what does the question say? The question says, the gist of this question, I'll spare you some time. There is a dipole which is placed in field. You just move the dipole, tilt it and leave it. You will see that the dipole will oscillate. The question is, find the frequency of the dipole if moment of inertia is given for small amplitudes. This word small is used. Okay. Now, whenever you get torque is proportional to theta, this constant, all right, this constant is like your torque constant or force constant. Okay. Now, did you guys get it? Now, did you guys get it? Yes, I hope now you guys got it, Krishna and Kat. I hope now you got it. Okay, so torque is P sine theta. The reason why I did it is because just like for SHM, F is equal to Kx, in angular SHM, torque is some constant into theta. That's the difference. Now I hope you guys got it. Okay, Crazy Gamer and others. Yes, that's the whole idea of this problem. Now, just like in normal SHM, time period is 2 pi under root mass by K. It's mass by K. But for angular SHM, what do you think it will be? Instead of mass, what will you put? Instead of mass, what will you put? You will put moment of inertia. Yes, moment of inertia. And instead of K, you will put this constant, because this is very similar to force is equal to constant into X. So this is very similar. So that constant K will come over here. So that will be PE. I hope this is fine. Correcto. Now the last thing, frequency is 1 by time period. That means flip this. So it will be 1 by 2 pi root of PE divided by I. That is the answer. Understood now? I hope everybody has understood this beautiful question. This, Kartika, I have already done that. Yes, it's already been done, but still I will check it out. Okay, if it is still blocked, I'll definitely try and unblock it. Definitely. Okay, very good. Okay, let's do that. Thank you, cool girl. Okay, now last few things before we wind up the class. Whereas force is constant into X, where has that X gone? Himanshi, that X does not come in time period formula. Time period is 2 pi under root m by K. It's not m by Kx, na? So that X does not come in the time period formula. Be careful. Okay? Yep. Now, my God, guys, you guys fight a lot with each other. Chill. It doesn't feel like I'm teaching 12th standard. It feels like I'm teaching 6th, 7th standard students. Oh my God. You are... I mean, if is Asmi here, probably Asmi should probably tell this. Yes, like 9th and 10th standard students have more fun than you guys. Guys, chill, take a chill pill. Yeah, please don't fight with each other. Potential energy, guys. So whenever you have a dipole and you place it in a field, then it also gets potential energy. And remember one thing, the potential energy is given by this formula. U is equal to minus PE cos theta, assuming this as reference. What is the reference? Theta is equal to 90 degrees is 0 potential energy. So when this is perpendicular, that is assumed as 0 potential energy. That is basically the formula for potential energy, guys. And from here only you get U is minus P vector dot E vector. This is the formula for potential energy placed of a dipole placed in somebody else's field. Yes. K is the constant. Yes, Himanshi. Correcto. Yes, K is the constant. Correct. Exactly. Okay. How this formula has been derived? Okay, I'll tell you how this formula comes. This formula comes by a simple technique. The work done, all right, goes in increase in the potential energy, and the work, just like it is integration of force and displacement, you can also write the work as integral of torque with respect to angle. Instead of F dx, it is torque d theta. So that is your final minus initial potential energy. And then you just integrate with limits. Potential energy final minus potential energy initial is equal to integration of torque, which is P sine theta d theta. Now you put the limits. Initially the angle is, let's say, 90 degrees. So my initial potential energy will become 0 and final angle is theta. So my final potential energy is U. That's it. You integrate, you will get the answer. Okay, that's all. That's all. That's what you need. So this is how it has been derived. Okay, cool. Now, what is the meaning of this potential energy? This potential energy tells you that if you place the dipole at different angles, you get different values of potential energy. So that means there are some places where you keep the dipole, it is more stable, and some places where you keep the dipole at certain angles, it is unstable. So some places the dipole will have more potential energy, some places it will have less potential energy. That's what it all means. So this derivation, guys, if you want, please join the pro subscription. We explain this in detail. So understand, due to time limitations, I have to keep this crisp and short over here, but this is the general idea of the derivation. Please understand that. Okay. Now, the special cases is what is very important. The special cases. The special cases are, first, when theta is 0 degrees, and next is when theta is 90 degrees, and last one when theta is 180 degrees. So all the special cases are here: 0 degrees, 90 degrees, and 180 degrees. Your homework. Yes, yes, you are right probably. Yep. Okay, so your homework is to figure out what will come over here. What will come over here? As in, will the torque be max, or will it be minimum, or will it be 0? What is the value? That's what you're going to fill out. Next, what is the energy? Is it P? Is it minus P? Is it 0? I don't know. So fill that out. And in the end, figure out what kind of equilibrium it will be. What kind of equilibrium will it be? That's it. Yes, that's all. So I'll tell you what, I'll just give you a hint. This one is stable equilibrium. I'll just fill some things for you. This one is nothing. This is not any kind of equilibrium at all, because the torque is not 0. In fact, I'll tell you, when the angle is 90 degrees, we just figured out the torque is in fact maximum. Alright, torque is in fact maximum, we just figured out, so it's not in any equilibrium. The last one is basically unstable equilibrium. Keep this in mind, it is unstable equilibrium. That's it, it is unstable equilibrium. Okay, so keep this in mind. Alright, cool. So fill up 1, 2, 3, 4, 5. 5 parts is what you need to fill. Alright, so just fill up these 5 parts. Very important parts. It will give you a brush up of the entire chapter. All right. Chalo. Let's do a question. Let's see how many of you can do this. Come on. All right. Andrew has already filled. Yes. Unstable means what? Okay. What is the meaning of unstable? Unstable means you displace the dipole little bit. It displaces even more automatically. Okay. You displace it here. It goes like that. The torque keeps pushing it away. Stable means you push the dipole, the torque winds it back. You push the dipole, again the torque winds it back. That's the meaning of stable equilibrium. Okay, no problem, crazy. So let's see how many of you can get the answer for this question. There is a dipole which is placed inside this field in stable equilibrium, and if it is rotated such that it goes into unstable equilibrium, how much is the change in the potential energy? Yes, Saksham, if it is in stable equilibrium, then it will always perform oscillation but need not perform SHM. See, SHM is a subset of oscillation. Oscillation means it just goes back and forth, but it need not do SHM where force is proportional to X. Okay? Yes. Having no equilibrium in between, Himanshi, means that, if you leave it in that position, it will not stay there. It's no longer in equilibrium. And it makes sense. When the angle is 90 degree, in fact, there is maximum torque. So because there is torque, there is no equilibrium. Okay, I hope that is also clear. Hi Gautam, welcome aboard. Okay, so now, guys, let's see if you guys can get this right. So first of all, the dipole was like this. Then you tilt it and make the dipole like this. First the angle was 0 degree, then the angle is 180 degree. The question is, what is the change in the potential energy? That means its potential energy when it was 180 degrees minus potential energy when it was 0 degrees. Final minus initial. Final minus initial. Akila, MSB, I'm guessing you are not a 12th standard student. So SHM is a 11th standard chapter. This is a course for 12th standard students. Okay, simple harmonic motion is usually done in 11th standard. So wait for it. If you are a 11th standard or other standard student or it has not been done, I'll be teaching it in the 11th standard course. Okay, great. Now, potential energy when it is 180 will be minus P E cos 180. Okay, minus P E cos 0. Remember, energy formula is P E negative cos theta. That's it. Now, what is cos of 180? Cos of 180 is minus 1. Correct? Cos of 180 is minus 1. Minus minus will become plus. PE cos 0 is also 1. Now minus minus becomes plus, so it will become PE plus P, which is nothing but 2 times of P, which is option D. Option D. I hope this is clear. Yes. Yes. What is the difference between having no equilibrium and being unstable? Unstable means you are at equilibrium, just that when you are disturbed, you move away. Example is, see, you have a marble at the bottom of a pot that is stable because you keep it there, it stays there. You disturb it, it comes back. Okay, that's stable. If you keep it like this on some dome, there also it will stay there, but it is unstable because if you disturb it, then it will fall off. Now, when you keep a marble here, obviously it is not in equilibrium because if you leave it there, it will roll off. That's the meaning of no equilibrium. So that's the difference between no equilibrium and unstable equilibrium. Okay, great. Okay, what about this question, guys? Okay, I think we need to wind up the class in 1 minute, last 1 minute. Okay, I'm going to wind up the class. There is a charged wire and there is a dipole. The question is, what is the force acting on the dipole if the dipole is like this, parallel to a long charged wire? Parallel to a long charged wire, what do you think is the force acting on the dipole? Believe me, this is the easiest question of all. Guys, think about it. Because of a charged wire, the field will be like this. This is how the field is going to be. This is how the field is going to be. I hope this is clear. I hope this is clear. Yes. Now, on the negative charge, the force will be like this. This is the force on the negative charge. But on the positive charge, the force is going to be like this. Think about it. The force on the positive will be there. Force on the negative will be here. Net force, 0. Because the magnitudes are same, directions are opposite. Khatam. Done, done, done. Answer is 0. Yes, that's the correct answer. No need to solve it also. Yep, that's the answer. Okay. Now, last question for homework. So please check it out. The electric dipole is kept in a non-uniform field. It may experience. Whatever you think the answer is, please drop it in the comment. I will upload the answer in the Telegram group and you will see that in the PDF. Alright. So do check it out. And guys, regarding how to join the pro subscription, well, I have very little time, but still I'll just show you. So what you do is go to any of the videos and when you click show more, alright, you will get over here a link for joining crash course or pro subscription. So when you click that link and you select your grade, like say for example 12th standard and you're targeting JEE Mains 2022, you'll get all the details. And when you say proceed to pay, alright, when you say proceed to pay, now you can select for 1 month or for whole 1 year till the next year. And when you say proceed to pay, and when you apply this coupon code SHHPRO, there is a beautiful option and that is EMI option, where you don't have to pay the entire amount. Already with a discount, you can choose no cost EMI options from different banks and you hardly have to pay few thousand rupees per month that is a very good deal because you don't have to pay a lump sum amount. So do check that out. Alright, that's it for today guys. I hope you have enjoyed the session and do not worry about the spammers and all, and please check out the Telegram group as well. See you guys tomorrow morning at 7 o'clock in the morning, Zero to Hero series on light waves and electromagnetic waves. Bye bye, take care. This was Shreyas here.